Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will talk about the applications of randomized numbers and how to get those applications up and running. So in our previous video on random numbers, we created a for loop and printed a random number, and we printed both pseudo-random and actually random numbers depending on whether or not we use the srand and a seed of 0. One thing to note is, why do we use time 0 when we call srand? Well, what this does is it seeds the function or the program with the current time of compilation. And what that means is that every time that we run the program, we get a new random seed. So that way, every time we actually run the program, we are getting different output every time that is unique. So going off of what we did last time, if I generate a list of 10 random numbers using srand and a call to rand and store that information into some integer r, I can check to see if that value is even or odd using the modulo function. So I can do this in two ways. I can either mod r and save that, or I can check r afterwards and see what is going on with r. So here in the if statement, I'm saying if the value is divisible by 2, then the remainder should be 0. Otherwise, it should be 1, and we should get an odd value, no matter how big or how small the number is. So let's test that out. We're going to print the number and then check to see if it's even or not. You can see here that the first number comes out even, the next one odd, and so forth. And that this is randomized. We're getting a series of odd numbers at the end, and if we were to rerun the program, we would get a different series of even and odd. So the next thing that we could do here is we could change this so that we could modulo this and just get the remainder. So if we did that, what we would actually be printing is just zeros and ones. We wouldn't actually know what the actual number r is. We would just be looking for the remainder of whatever number we generated. Okay, moving on. Close this. Okay, so we're going to comment out this, and we'll just leave this as it is. And now what we're going to do here is we're going to go down and talk about using percentages. So say we take the same seed, and this time, instead of generating a bunch of numbers, we're just going to generate one number, and we want it to be some percentage out of 100. Well, we can change what we use the modulus on the rand function to produce some kind of result like that. So no matter what we generate from rand, when we modulo it by 100, we're going to get a remainder which should be greater than 0 and less than 100, which we can use to then generate a random percentage. Oh, I already declared this, that's why. So I'm going to go ahead and compile this, and you can see that we're getting 38% from the value num. If I was to recompile, we should get a different percentage. And we do, we get a different percentage. And this is going to keep going no matter how many times we call it. We're going to continuously get new percentages. Oh, we got very close to 100 this time. And this is very useful when generating any kind of a simulation or playing any kind of a video game or something like that, when you need to generate some kind of an action based on some value. So here, let's talk about generating, say, a dice roll. Say we want to change the range here so that it's not just static based on 100, what we can do is we can actually set a custom range by specifying both a max or min. In the previous example, we just gave it a max, meaning that the threshold of all values would be no larger than 100. In this next example, what we're going to do is create an integer called dice roll and specifically set a range between 1 and 6. Notice that the formula to use this is to say that the integer will equal the call to rand modulo the max value in the range plus the minimum. So we're specifying that it can be anywhere between 1 and 6 here by doing this. So let's run that and see what we get. Oh, I didn't print it. So here, let's print out dice roll. And now see what we get. So we get a 3. And if we recompile again, we get a 2. Recompile again, we get a 4. So every time we're doing this, we're getting a completely different number. And this might come back more than once. And that's good. That's exactly what we wanted. We wanted it to be within the range of 1 to 6, and that is valid. What we can also do is we can generate floating point values as well. So we've been working with integers up to this point, but if we wanted to use floating points, we could by multiplying by a floating point like 1.0. And in this case, we're going to divide by rand max. So one thing I'm going to do here is I'm going to actually print rand max. And show you what this looks like. So rand max will be the max value that could be generated at any given time by the randomized function, which is usually the largest value that can be stored in an integer. And this happens to be that number. So here you can see that when I print num, which is a double, we're getting a value of 0.895131. And this is coming from the fact that we're taking a number, multiplying it by 1.0, which is double. So this number, rand times 1.0, is going to be some number that will be between 0 and 1 by dividing by rand max. So we're getting something very, very, very small. And every time we run this, it should be a uniquely different decimal value. But notice that rand max is static. It will always be the same. That's all for this video. Thanks and happy coding.